Welcome back. Today we're going to cover some linear equations again, but I'm going to show you a much more realistic way to come up with those magic equations. And once we have the equations, we can predict the future. Well, we're going to use your calculator today.
My secret weapon!
So I'm telling you, whether it's a TI 83 Plus or TI 83 Barbie model, whatever you want, go get it.
I say this calls for action, and now!
And you need to turn or pause the tape, but I need you to have it in your hand, so go get it now. Okay, because we're going to use it right away.
This is a job for you know who.
Okay, I'm going to give you a tour of what we're going to use today. In reference to the calculator, there's a lot to cover, but we're only going to use it today to plot some points, ordered pairs. Okay, now some of the buttons we're going to be using.
Oh, boy, is this great!
We're going to do easy points. Some of the buttons, and make sure you know where they are. Of course, the on button. Don't have to hit it right now, but the enter button, when I say enter, that's what I want you to hit right there. The graph buttons right there. The stat button, we're going to be using that a lot. Okay? And the y equals button or stat plot. Okay, look for that. And to get anything orange, of course, you're going to use the second button. Okay, you'll hit second and then the specific button. For instance, second on, as you can see, turns the calculator off. And there's stat plot. Second y equals gives you stat plot. Now that's the L1, but we're going to call it list 1. Because we're going to be actually, to put in points, we need their pairs, we need to put in 2 lists. So that was list 1, and this is list 2. And when I speak of the cursor keys, you probably knew this, but that's the cursor key. So cursor up, cursor left, right, and down. And that's the clear button. Okay, so here's what I'm going to do. We're going to do it twice. Turn that baby on if it isn't already on. And I'm going to hit stat plot, which means I'm going to hit second y equals. Now, unless you've changed your calculator, it's set to graph lines, continuous lines, which is basically an infinite number of points. We want to turn it on so that it graphs basically a limited number of points. It's called plotting them. So we're going to turn plot on. And I'll show you how to do that. And then you're going to clear to get back out. Then we're going to start putting them in. Inputting the points. And all statistical type stuff is done under the stat button. So you would hit the stat button, and we're going to actually enter them by editing. And I'll show you what's going to happen there. And we'll enter the points. Now you can either enter the points via the cursors, or you can use the enter button. And we'll hit graph and we'll actually see these 3. Should be only 3 points. Remember, 2 numbers make up a point. As you know, we hit clear to get out of here. Now, you might have had trouble following me because I went pretty fast. I'm going to do it again, and you watch me do it. Let me bring up my calculator. Basically, remember what we're doing here. We're turning the ability to plot on and to actually draw individual points, and then we're actually entering the points. Okay, let's turn the calculator on. You can follow my cursor with on. And now I use stat plot, which is up here. It's not on the stat button. It's up here above y equals. So I have to hit second y equals. And I get into stat plot. And I can see that the plotter is off. There's 4 of them, but I'm just going to do one at a time. So I want to turn it on. So I can either hit 1 or enter. And I see that the off is shaded, so I need to cursor to the on and hit enter. And I can see now that on is shaded, and I'm in good shape. The plotter is on, and you can see that the plotter is on up here as well. So I'll clear to get out. Okay, now the plotter is on, but it doesn't have anything to plot. So I'm going to put in some points, and basically you put in points by editing the lack of points. So I'm going to hit the stat button, And the stat brings me up to the stat menu. The first thing option I have is to edit, and that's what I'll do. Okay, since I'm on number 1, I don't have to cursor. I can just hit enter. Okay, now there's no points in here, so I'm going to cursor around and put them in. I'm going to put a 1 here, and I'll hit enter. And then I can cursor up. That's the hard way to do it, and put a 2 and hit enter. Remember, your cursor keys are over here. Now if I want to do what I think the easy way is to just forget the enter and just cursor, because it's gonna input the number. So I'll put a 3 here, and if I cursor down anyway, it puts it. And let's see, what am I going to want here? I'm going to want a 5. And I'll cursor off. It's like a little spreadsheet. And I'll put a 4 here, and cursor down or hit enter, and a 6 here, and just cursor. I'll just hit enter there. Okay, now so you've got the point 1, 2, the point 3, 4, and the point 5, 6. I've entered them, so I should be able to see them because the plot is on. So I'll hit graph, and son of a gun, there they are. Now there must be a line that's still in here from a previous problem, and we'll get rid of that. Let's hit y equals, and I can see there's x plus 6, so I'll clear. Now hit graph again. There it is, and there's all my points. Okay, and remember how we get out to the main screen? We hit clear. Very good. Now we want to go over everything. Suppose your Aunt Minnie is going to use the calculator next. You've left it with plot on and all these points, and they're going to be on the graph if you leave it that way. I want to show you how to take all the information we just did, take it back out of your calculator. To get your calculator set back to the way it was, we're going to hit stat plot. Why did we go into stat plot? That's to turn plotting on and off, and we'll turn it off. Okay? And that'll clear will get us back out to the main screen. Now we'll still have the data in there, and if we want to see it, we can turn plot back on. If we want to get the data out of there, here's one way to do it, and there may be way more than 3 points, so this is probably a more efficient way than doing it one at a time. One of the options under stat is to clear a list. Now actually these points are 2 lists. All the x's where the domain is a list, and all the y's where the range is a list. So I'm going to have you go to stat clear list, and it's going to ask you what list. Well, you'll say list 1 by hitting second and the number 1. That'll get you the L1. And then hit enter. And that will clear all the x's, even if there's 500 of them. Then I'm going to have you hit stat again, clear list, which is number 4. And of course we have to clear the second one. So we'll answer that question with L2, which you can't just type L2. You'll have to hit second and the number 2. And then enter. And that will get rid of all the ones in the second list, or all the y's if you would. And if you hit graph, you should see nothing now. Okay, and remember how to get out. You set it back to the way it was. Okay, you're a good, responsible calculator user. Let me try it now. Let me bring up my calculator, and I'm going to hit, let me turn it off first. The stat plot, I mean. So I'll hit second, stat plot, and I can see that it's on. It tells me right here that it's on. So I'll hit 1 or enter. Cursor to off. Remember where your cursors are. Cursor to off and hit enter, and now it's off. Okay? And I want to get out of there with clear. Now if I wanted to get rid of the data, maybe it was secret data, I have to get into stat. Remember, all the editing of the data is subordinate to stat, the specific data. So I hit stat. Now I was in edit, okay, and I could go into edit and delete one at a time, but I can get the whole list with number 4. And I'll cursor down, do it the hard way first, cursor down, and I'll hit enter on number 4. And it'll say clear list, what list? And I want to tell it L1. Remember that L1 is down here, but it's orange. So I'll have to hit second 1, and it actually types an L1 for me, and I'll hit enter to tell him that I'm sure, and it tells me that it did it. It cleared it out. Okay, now I still have to clear out the second one, so I'll hit stat, once again clear list, but this time I'm too lazy. I'm going to hit 4, and it says which list. Well, I still got to get list 2, and here's list 2 down here, but I can't hit the 2. I have to hit the L2 or list 2, so I'll hit second and list 2 and then enter, and it's gone. You don't believe me, I bet. So we'll hit graph, and everything's gone. Okay, remember how to get out? We'll hit clear. Okay, very good. Don't forget, you can stop the movie at any time, pause it at any time, and try this on your own with the directions like this. Okay, now we're going to do it a couple more times because I need you to be very comfortable with entering data, because it's going to be most of your homework in the tests. Let's do another relation.
Bring it on.
We're going to put in this set of pairs, 4, 1, 3, 1, 2, 1, and 5, 1. Now we had already, hopefully your calculator is set the way that we had already cleaned it up, so we're all set. And plot is off at this time. Let me give you another tour of the buttons, just in case you've forgotten. Of course, the on button, the enter button, the stat button, the y equals, also known downtown as stat plot, if you hit the second. Okay, and there's cursor keys, the graph button, there's the second, that's the way we're going to get our stat plot, and there's stat plot. There's list 1, of course you have to hit second 1 to get list 1, and there's list 2, and I'm sure you can imagine they go all the way out through 9, and there's my clear. Okay, I don't think you have to turn it on, but if you do, go ahead and do so. And we're going to hit stat plot again, second y equals, because we're going to turn the ability to plot back on. Okay, remember how to do that. You're going to cursor to the on and hit enter. Okay, now let's get out of there. We've turned plot 1 at least, plot 1 on. Okay, now we're going to enter these points. We enter that via stat, and you can either hit enter or 1 to enter into the editor. Okay, now go ahead and put those points in. 4, 1, 3, 1, 2, 1, 5, 1. It's probably easier just to work your way down the X's, 4, or however you want to do it, 4, 3, 2, 1, or I'm sorry, 4, 3, 2, 5, and then just put all 1s in the Y area, the list 2. And once you've done that, go ahead and hit graph, and son of a gun, you should be able to see how many 4 points, and they should kind of line up. I thought you probably expected that. And remember how to get out of that. Clear. Okay, let me see if I can catch up with you. Bring up my calculator. Okay, I'm going to clear out of this, and I'm going to hit, it's already on, so I'll hit second plot to get into second y equals to get into stat plot, and I'm going to turn plot back on, so I'll hit enter, cursor to the on, and hit enter, and now I can see that it's on, and I'll clear out of there. Now let's get this data in there. Get in data via stat, and I'll go into the editor. I'll hit 1 or enter. Okay, now let me cursor over, and I'm going to do this the fancy way. I'm going to use just enter. I'm going to hit 4 and enter, 3 and enter. Notice I don't have to do them in order. 2 and enter, because there's a place somewhere. 5 and enter. There's a place somewhere where I can actually sort them. Okay, now I'm going to cursor up a couple times, cursor over, and I got to put 4 1s in, don't I? 1, enter. Notice it moves down. 1, enter. 1, enter. And 1, enter. And I think I have the points 4 1, 3 1, 2 1, and 5 1. Okay, I don't believe it. Let me hit graph and see. There they are. There's those 4 little points. Not very impressive, are they? But we'll be getting way more points in the future. Want to go slow now. Okay, how do we get out to the main screen? Hit clear. Very great. Okay, by now I hope you're getting pretty good at this. Okay, so I'm going to give you a little bit of a challenge.
How about a little fire, Scarecrow?
I'm going to have you, without clearing anything out, we're going to enter these points. 11, 12, 13, 14, and 15, 16. Okay? We're going to delete the old ones. We're not going to clear the lists out. We're going to do it by hand. We're going to delete the old points. I want to show you that you can use this button as well. Okay? So I'm going to hit, remember I don't need to do stat plot because plot is still on. I'm going to hit stat. That's the one I use to actually enter and remove and change data. And I'll hit edit. And I want you to actually go to the old points and hit the delete button. Remember where the delete button is. And just remove that data first. And once you've removed that data, insert the new data. 11, 12, 13, 14, 15, 16. Okay? Of course, the way we insert data is via cursoring to the appropriate place, typing the number, and hitting enter, or cursoring off of that area. Just like a little spreadsheet, remember?
Houston, we have a problem.
Now if you graph, go ahead and hit graph, you're going to see that we do have a problem. Maybe I went too fast for you. Let me do it again. Okay? Bring up my calculator and I'll hit stat and edit. Although I just have to hit 1 or enter. And there's those old points. Let me hit my delete. Delete, 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 and I'll cursor over and delete, 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 delete. Now everything's gone. Let me put in the new points. 11 and enter. Let me cursor up so you can see what I'm doing. And 12 will go here and enter. And I'll cursor over. I want a 13 here and enter. And up and over. And 14. So I took out the old points and I'm putting in the new ones. Okay. Up and over and 16. Okay, now I have the new data. I'm getting pretty good at this. Problem is, if I hit graph, I'm not seeing them. What's going on here? Why am I not seeing them? Well, remember how to get out. Let's hit clear and we'll talk about this. You did everything right. The data's in there and the points are in there. We're just zoomed in too close. Of course, we're at the standard zoom unless you've changed it. We're at this. We're looking at it too close. 15 and 16 and 11 and 12. They're way outside of the current window. So let's use our buddy zoom. Where's the zoom button? Remember zoom? Okay. Now I think you're at a zoom standard. That's where we left it last show. The things that are available to us are to zoom to a specific box. See if I can demo that for you. Zoom in. Zoom out. And I don't use the other one. Zoom standard, of course, we've used already. That's to set it back to the standard window. Okay? And zoom stat, that's going to make all the points fit. Ooh, we like that. Make all the points fit. That's going to be another nice one.
Baby, you're the greatest.
Or zoom fit. Now that doesn't fit the points. That fits other stuff, like lines and parabolas and such. Okay, so what we're looking at, I think we want 9. Let's take a look and see what happens. Okay, now I know if I hit graph, I'm not seeing anything. But I'll hit zoom, and I'm going to cursor down. I know there's a 9 down there somewhere. That arrow tells me there's more. There it is. Zoom stat. So, and of course I can hit enter now, or 9. And look, it boxes just the specific points, those 3 points. Now, this isn't the axis, okay? This isn't the axis. This is just the window. If I want to zoom back to my normal window and not see them anymore, I would hit zoom and standard, which is 6. I propose to you that you probably want, so you can get some sanity, so you can see your axes and your points. Let's zoom out. So I'll cursor down to 3 so you can see what I'm doing, and hit enter. Now when you zoom out, you have to hit enter a couple more times. And there it is. There's the 3 points. Of course, it looks like we're far away because we are. Okay. Another thing we could do is zoom box. Let's get a just perfect. What I usually do is zoom out and then I zoom box. Watch what happens when I zoom box. I'll hit the 1 and it asks for the box. So I'll use my cursors. See my little crosshair moving as I move up, and it's asking for the top right of the box that I want, and I'm going to use that position right there, and I'll hit enter. Now it's asking for the bottom right, and I'll cursor down, and you see as I cursor down it's forming a box. I'll cursor down and over. So I hit the top left, and now it wants the bottom right. And I want to get the axes in there. I'm hitting my cursors. That's about good. And you can see you got a box, and now you got to finalize it with enter. And how cool is that? That's perfect. That's just what I want. So a common thing to do is either to hit zoom stat, of course you might lose your axes there, or zoom out, way out, and then zoom the exact box that you want. Then you really can have anything you want. How sweet is that? Let me leave it in zoom standards for my own sanity. Zoom 6. Of course it's not good for this problem, but we'll come back. Okay, I'll clear out, and I'm back in the ball game. Okay, now what the heck does this have to do with linear equations? These dots, these points. Well, let's remember the slope-intercept form. We covered this last time. Remember, you can always put a line in the form y equals mx plus b, where the number in front of x is always the slope, and the constant, is always the y-intercept. Okay, we can always put it. It's going to be very useful today, so remember that. For instance, in this problem, y equals minus 2x plus 7, the slope is negative 2, and the y-intercept is 7. And that's not to say that the first number is always the slope. I said the number in front of x. So in this case, the slope is 3, and the y-intercept is minus 5. In this case, the slope is the number in front of x, and there isn't an x, so the slope is 0, and the y-intercept is 15. And in this case, the slope is 3/5, and the y-intercept is 0, because there isn't a constant. Well, there is, it's just 0. Okay?
Now then, boy, we'll see how much you learn.
I'm going to ask you to find the linear equation
A clue.
with this clue. It's going to go through the point 2,5 with the slope of negative 2. Now this should be reviewed to you. We're going to, right away we can put the slope negative 2 in its position. Remember, we're always looking for an equation. Now, how are we going to find the rest of the equation? All we really have to find is that b, or that y-intercept part. And we have another clue that the point 2,5 is on there, so it fits. So 2,5 being the x and the y, I can put, instead of x, I can put a 2, and instead of 5, I can put a y. And what b will make that work? Well, let's see. Negative 4 plus what? I can't do it in my head, so I'll add 4 to both sides. And apparently b has to be 9 to make this work. And I've come up with the magic equation. Why do I want to come up with magic equations? I want to make sure you understand this. Because once you have an equation, you can use the equation to get future points. We can actually, you know, in chemistry, physics, and all kinds of business, we can predict the future, basically, if we have this magic formula.
Oh, good grief.
Let's do a couple more, because I think you forgot this. I want a linear equation, y equals mx plus b, with a y-intercept of 8 and a slope of minus 4. Well, this one's really easy, because they give me the numbers. Just have to know where to put them. The slope is minus 4, and the y-intercept is 8. And I could use that formula. I could use that formula to find many other pairs that work. Okay? Starting with the formula and then going to the points. Don't forget we can use the slope-intercept formula. Okay? I'm sorry, the point-slope formula. Remember what that was? The difference in the two y's of 2 points over the difference in the two x's of 2 points will give you the slope. In this case, I think you remember this problem was about temperature. 212 minus 32 over 100 minus 0. y2 minus y1 over x2 minus x1. Let's see what that comes out to. Let's see, 212 minus 32 is 180, and 100 minus 0 is 100. Well, let's reduce that. And do you remember from last time we got 9/5, and that's the slope. And we could put that slope in, and then we could pick either point. I'm going to do the easiest point, the one with the 0, because I love 0. He's easy to work with. And I can use that other point to find out what the b is. Let's see, 0 times 9/5, even I can do that. So b has to be 32. And that equation was the conversion equation, you may remember, to go from Celsius to Fahrenheit. And this is the beauty of this. You see, once I have the equation, I can put in various numbers and complete points. I can figure out, well, geez, what is 20 degrees centigrade Fahrenheit as a Fahrenheit temperature? Well, I put in a 20. I have to reduce. Let's see, 20 divided by 5 is 4. 9 times 4 is 36. 36 plus 32, you may remember, 20 degrees is 68 degrees Fahrenheit. And I could do that with any temperature centigrade because I have this formula. Okay, so what we've been doing up to this point is take a formula and use it to predict points. And these points were exact. Well, I got to tell you, I've been spoiling you a little bit.
Oh, dear. That's too wonderful to be true.
It is too wonderful to be true. Because
You can't handle the truth.
in real life, things, for the most part, don't come out exact. We don't have exact points. People, a batter doesn't always, every day, bat his exact batting average. Sometimes he has good days, sometimes he has bad. It comes out as an average, but stuff happens, okay? Thermometers sometimes don't work exactly properly. People don't exactly work properly, okay? So things don't always come out exact. So to that end, we have another method, a way more realistic method to find these equations, and that is using what's called linear regression. We call it regression because up to this point, we've been going from the equation to the points. Now, I'm going to give you a whole bunch of points, and they're not going to line up very well. They're not exactly anyway. And you're going to regress, you're going to go backwards, back to the line. Much like the point-slope formula, but that only found you the slope. I'm going to give you a bunch of points, and they're going to actually allow you to find not the exact line, but an average line, if you would.
Hey, man, check it out, huh?
For instance, if I had a bunch of points here, and I see they don't line up, I told you stuff doesn't always work out. And I had measured these points as temperature or something. Temperature versus date or something. Now, there is a line that's pretty close to them, okay? And that would be close enough for my sake to predict, some other points, if you would, in that trend. Here's another one. Now this one goes a different way, but it's still an average line for those points. It's not always a line, and it doesn't always work. These points are all over the place, and if I drew a line, it wouldn't be very good. Okay, so it doesn't always work. And sometimes it isn't a line. Sometimes it's a parabola. Now, we're not going to be dealing with that in this semester. We're just going to do linear regressions. Okay? But if we can find that function that predicts on the average where these points are at various spots, once again, we'll be able to predict the future.
You'd like that, wouldn't you, boy?
Oh yeah, it'll be quite useful. So to find linear equations,
Plastic machine, Spock. You can't argue with a machine.
we can use our calculator if we can input points. Well, get out of this town. I just showed you how to input points, and then the calculator's going to give you the equation. We're going to be using stat to input points. Remember, I just told you how to do that. And we're going to plot some data points, and then, of course, we'll look at the picture. If we hit stat calc, I'll show you where that is in a second. There's an option under stat calc called linear regression, and if all those points are in there, it's going to look at those points, and the calculator will figure out the average line, the ax plus b equation that you can use. Now, there's a lot of math to this, and actually we're not going to do the math. Okay, I just want to show you how to do it on a calculator. It'll be great, of great use to you. Okay, and that's kind of the method we're going to do.
We went from good to sensational.
And it's gonna give me an a, which is going to be basically the slope, the number in front of x. It's going to give me a b. You're used to that. That's going to be the y-intercept. And we'll talk a little bit later about what the other two numbers it gives us are, the r's. Okay?
I know that, dude.
That's the slope, the first number it gives us.
I know you are, but what am I?
And that's the y-intercept, the second number it gives us, the b. You already knew that. Okay?
Pay attention, boys. I'll show you how it's done.
Okay, let's see. We collected this data from 10 students last semester. The blue numbers are all their homework, their final homework grade, and the green numbers are all their final exam grade. And we think that they correlate to each other quite well. Okay, well, we're going to find out, first of all. Okay? Now, first thing we have to do is get this data into the calculator. Okay, let's get moving. You're going to have to plot it. Remember how you do it. You use the stat button. Okay, let's get that data in. I'm going to do it with you. Here we go. Bring up the calculator, and I'll go stat. And the plotter's already on, so all I have to do is go into the editor. And I'm going to go over and put in my numbers. I'll read them off for you for list 1. 85, enter. 35, enter. 60, enter. 79, enter. 100, that was mine, enter. 90, enter. 41, enter. 65, enter. 95, enter. 71, enter. Okay, now let's get back up to the top of list 2. We'll cursor over and up, up, up. Okay. Gotta go all the way up to the top. Don't think you're up to the top until you're next to that 85. Okay. Now let's see. 136, enter. 40, 40's next to the 35, enter. Okay, 88, 88 next to the 60, enter. 125, enter. 165, enter. Now these are exam grades out of 200, okay. 145, enter. 52, enter. That person didn't do their homework. 98, enter. 155, enter. and 111, which should be right next to a 71. You did it right. Enter. Now we've got the data in. Let's graph it, make sure that we can see it. Well, what's going on here? We have to zoom out, don't we? But it's there. In fact, I'm not even going to take the time to zoom. Let's clear, and let's get a regression line. Let me show you how to do it. We're going to go into Stat, hit your Stat button. Now you do not see regression on this, because this is the editor. We're going to have to move over to a different menu under Stat called Calc. The way to move over is to use your cursor. Okay, so hit your cursor, and you'll see Calc will become darker, and you'll see a bunch of things. We're going to use number 4, linear regression. Remember I told you there were other types of regressions, quadratic regression, cubic regression, etc. But in this class we're only going to do linear regressions. Okay, so you can either cursor down, I'll cursor down to 4 so you see where I'm at, or you could just hit 4 and hit enter, and it's going to go when I hit enter and sniff that data and figure out the best line, the average line if you would, that will fit through them to be closest to all those points. I'll have to hit enter again. Took a little number crunching, but as you can see, in the form y equals ax plus b, it's telling me that if I write an equation that has a slope, the number in front of x, of 1.919412739, geez, is that close enough for you? And a y-intercept of negative 26.31, that's close enough for me. Okay, that's gonna work out for us. Well, let's try this. Okay, let's clear that out. Okay, and I'm going to put, as you can see, I've already calculated that y equals 9.14. Now I asked you to find the regression line. That's what I mean, the y equals mx plus b line. And we found, basically, I'm rounding, y equals 1.9x minus 26.3. Now who cares? Well,
are you pondering what I'm pondering?
now that you've gotten all that old data and you've put it into a regression line, you can use that line to predict other people's grades, okay, or predict the future, as I said. I'd ask you to predict the exam grade of a student doing only doing 50% of his homework. What do you think that person's going to get based on the regression line from this data? Well, let's use our calculator. We can type that line, let's clear out, as 1.9x minus, we're trying to find the y with an x of 50. So I'm going to type 1.9 50 times 50 minus 26.3, and that'll give me y, which is supposed to be the final exam grade. This person got about a 68.7. We predicted using our linear regression line that this person's going to get a 69. They're going to fail, and that's predictable since they only did 50% of their homework. So we can use this regression line to predict all kinds of things once we have it. And how did we get it? Well, we regressed back from some earlier data. That's what we did. Now,
Hey, Doc, wait! I want to ask you something.
okay, we know that the A goes in the slope part, the number in front of the x, and the B is the y-intercept. What are those other numbers? Well,
All in good time, Minus Pretty. All in good time.
I'm going to tell you, relax, Frank. Those are the correlation numbers.
Do you mind telling me what this is all about, mister?
Okay. Well, a correlation measures the quality of a forecaster. Let's look at these two. Okay. Given that data, we have the green forecaster line and the blue forecaster line. Who do you think is a better forecaster of the data? Of course, one has much widely more scattered data. Okay.
Certainly.
So, yeah, you're the one that's closer to all the data. So some lines are going to be predictors, but they're not going to be very good predictors. Correlation is a measurement of how good a predictor it is. Okay, not just that. It tells how well it fits. Now it's always going to be the number they give you for the correlation, the R if you would, is always going to be between the numbers -1 and 1. If it's close to 1, that means it's a good positive correlation. That means as the X value gets bigger, the Y value gets bigger, and it's a good predictor. Okay? If it's close to -1, that means it's a good predictor, but it's a negative predictor, meaning that as the X value gets bigger, the Y value gets smaller. But that's okay, I can deal with that. But it is predicting, it's just predicting inversely, if you would. If it's close to 0, then it's not a reliable relationship at all. For instance, this one would be a pretty reliable positive correlation. Okay, the points are pretty close to the line, as you can see. And as the X value gets bigger to the right, the Y value gets taller, goes farther up. Okay, and this happens to be, if I put those points in, trust me, comes out to 0.816, and that's about 1. That's close to 1. Okay, not perfect though, is it? It's not a perfect predictor. That's life. Now this one would be a pretty reliable negative correlation. Notice as the X gets bigger, the Y value goes down. Okay, but it's still a good predictor.
Excellent.
Okay, in fact, it's a -0.829. It's very close to -1. It's called the correlation coefficient.
Whoa!
This is a terrible correlation. The points are all over the place. If you tried to use this line to predict anything, you would be a fool.
Oh, very bad. Definitely unacceptable. Yeah.
It is moving up a positive slope, so it is a positive correlation. But look how close it is to 0. 0.008. Almost no correlation at all. It's just a coin flip, really. Okay?
Allow me to demonstrate.
Okay. Let's do it again. If we take the statistics from the last 7 4th of Julys, okay, I'll just try and relate two parts of the data. I'm going to try to relate the number of riders on the Metro on the 4th of July, each of these last 7 4th of Julys. That's in blue. And that's in tens of thousands. Okay? And then how does that relate to how many car accidents occurred in the district on those 4th of Julys? We can use this linear regression, perhaps, if it's a good correlation, to predict how many car accidents are going to be on that day. Why do we care about that? Well, that's going to allow us to perhaps figure out how many police officers to have on duty that day, or how many ambulance people to have on duty that day. It's going to be of great use. Okay, so that's why we want to be able to predict type stuff. Okay, well, it's your job. You got to clear out that old data and plot the new data. So get moving. Get that old data out of there and put the new data in. You're going to use, remember what you're going to use, the stat button and then the edit button. Okay, let's give it a go. If you can get the data in, the calculator, of course, will do the rest. It'll calculate your regression line. So let's see. I'm going to hit Stat. Got to turn it on. Hit Stat and the editor, which will be 1. And let me get in here, and I'm going to start deleting and putting in numbers. Or overwriting even. I'm going to put 102, enter. 145, enter. 167, enter. 80, enter. 156, enter. 220, enter. And 99, enter. Now the rest of these values I'm going to have to delete. So I'm just going to delete, 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 and I'm down. Okay, now let me get to the top of the list 2, right across from the 102, and I'll put a 22, enter. 19, enter, 15, enter, 26, enter, 14, enter, 9, enter, and 20, enter. 20 should be right across from 99, and the rest of the numbers I'm going to have to delete, so I'll use my delete button. Delete. I need about 3 deletes, it looks like. Okay, and they line up. The 99 lines up right across from the 20. Okay, now my graph's probably too far in, so I'm not even going to worry about looking at the graph. Okay, what I'm going to do is create a linear regression line. Remember how to do that. I'm going to click on Stat, and then I'm going to have to move over to Calc because I'm telling the calculator to calculate this for me. So I'll cursor over to Calc, and the linear regression is number 4. So I'll cursor down to that and hit enter or hit number 4. And it's asking me, do I want a linear regression AX plus B? And I sure do. So I hit enter. Takes a little while, and son of a gun, it's where the slope is minus 0.111 something, and the y-intercept will be 33.3 something. I hope that's what you're getting. Okay. Now the correlation value is very good here. Okay, do you see that the R is 0.959? That's very good. That's very close to 1. And R squared is just the square of that. Okay, so it's a negative correlation. So as the X gets bigger, in other words, the more metro riders we have, the less car accidents we're going to have. So we may want to pump up and maybe let people ride the metro for free on the 4th. I think they did that actually a couple times. We predict, how would we use this data to predict how many accidents we think will occur in DC with 50,000 people riding the metro? Well, let's write the equation. The slope will be the A value, negative 0.11, times the 50, so I'll put it in parentheses, plus the y-intercept, plus 33.3. Close enough. Enter. With 50,000, it predicts 27.8 people. There'll be 27.8 accidents. Huh. I'd hate to be that 0.8 person. I wonder how many accidents would occur if nobody rode the metro. If nobody rode the metro, that's pretty easy. You can do it in your head, but let's just show you. It would be negative 0.11 times what? Times 0 plus 33.3. So the prediction with nobody riding the metro, the little course is higher. We're going to have 33 accidents, 33.3 accidents. So you see how we can use a regression line once we put in the data to predict the future and hopefully use that for various things to react to. Okay? Okay, we learn by doing, so let's practice one very last one. Don't fall asleep on me. Here we go. This is data from the last 7 Redskin games. Okay, now I like to eat pickles during my Redskin game. And I've measured exactly how many pickles I ate during each Redskin game and the points that the Redskins scored that whole game. That's in green. Now I'm wondering if maybe the number of pickles that I eat during a game is related to how many points scored by the Redskins. Well, I can find that out by putting in these pairs into my calculator and doing a linear regression. Let's see. Let me get my calculator and do just that. I'm going to go into Stat and I'm going to replace the old data with this new data. So let me clear out. Go into Stat, Edit, and I like to go down the X, the L1 column. So I'll hit 4, Enter, 7, Enter, 9, Enter, 2, enter, 9, enter, 8, enter, 11, enter, and I think it's time to go over to the next column. And this is the points scored by the Redskins. So 16, right across from the 4, enter, 21, enter, 14, enter, 7, enter, 35, enter, 26, enter, and 42, enter. Okay, now the data's all in. I'm going to let the calculator do the rest of the work. I may be on to something here. Let's see. I'm going to go Stat, move over to Calc, use your cursor, and I'm going to tell it to do a linear regression. So I'll cursor down to number 4 and hit enter, and enter again. And this is going to be a fairly reliable regression line. I see that my correlation coefficient is 0.8 something. So and it's a positive number. So as I eat more pickles, the Redskins seem to score more points. Geez. I wonder if I ate 100 pickles, how many they would score. Well, let me figure out. Okay? I might be dead, but that would be AX plus B. So it's going to be 3.16 times 100 plus 0.42. And I'll hit enter. Wow, they'll score 316 points if I eat 100 pickles. I don't think I can eat 100 pickles. I can eat 20 pickles. Let me try that. 3.16 times 20. I'll be sick, but they may win. Plus 0.42, and I'll hit enter. If I eat 20 pickles, the Redskins are going to score 62 points. That should be enough to win. All right.
Hasta la vista, baby.
Have a good one.